Mathematics Level 4, Topic 2, Module 5. Topic 2, Functions in Algebra, Module 5. Module 5, Session 1. Session 1 will cover the following content. Learning Outcome 2.4.3, the third part. Use the product and quotient rules for differentiation. Learning Outcome 2.4.3c. Use the product and quotient rules for differentiation. The product and quotient rules. The next two rules give us another way to deal with more complex differentiation problems. In this case, the complex function that we need to differentiate can be seen as being the product or the quotient of two functions that can be differentiated. The product rule states that the derivative of the product of functions f of x and g of x is equal to the function f multiplied by the derivative of g plus the derivative of f multiplied by the function g. Work through the following examples on your own or in pairs. Differentiate with respect to x using the product rule. Number 1. E to the power of x multiplied by the natural log of 2x. Number 2. Y equals 2x multiplied by the square root of x squared plus 1. Let's watch the solutions.
Differentiate with respect to x. Y is equal to ex times ln 2x. Remember, the previous example was the product of two algebraic expressions. Now we have another product here of an exponential and a logarithmic expression, which means we will apply the product rule again. So we start by let u be equal to my first expression, which is exponential, and v be equal to my second, which is logarithmic. I think you can clearly see we've dealt with this already. According to my formula sheet, du dx. Go to my formula sheet, formula number 12, ex remains ex. dv dx, again, once again, my formula sheet, remember we've dealt with this before, formula number 11, k is 2, so it's going to become 2 over 2x, which is equal to 1 over x. Next step, write down my formula for the product rule, formula number 8. It will be the first, which is u, times the derivative of the second, which is dv dx, plus the second, which is v, times the derivative of the first, which is du dx. And now I substitute. What was u? Ex, square bracket, 1 over x. What was v? Ln 2x, square bracket, ex. And then I can now arrange it in a better form, which means it's going to be ex over x plus, it's better to put ex in front, followed by ln 2x. And that is my final answer. Differentiate with respect to x. Y is equal to 2x square root x squared plus 1. What do we have here? We have the product of two algebraic expressions. The first one is 2x, and the other one is the square root of x squared plus 1. It's important to identify that we are going to use the product rule here. And the formula for the product rule is illustrated in formula number 8 on the formula sheet. So you're going to let your first algebraic expression be equal to u. You start with a statement. Let u be equal to 2x. And you're going to let your second expression be equal to v x squared plus 1. Obviously, the first one is fine, du dx. That is equal to 2, because the derivative of 2x is 2. But this one, I cannot find dv dx if I don't write that in standard form. X squared plus 1 to the power a half. And I cannot find, no certs, no certs. And the cert is a fractional power. Now only I can find dv dx. Remember the derivative of that which is inside the bracket, which is 2x. Obviously, if I want to be more precise, plus 0. And then after I've solved inside the bracket, then outside. Please don't become gerook here. You need focus inside times outside the power. A half bracket, a half x squared plus 1, a half minus 1. Can you see the previous knowledge? What does this give me? 2 and 2 will cancel out, so you're going to have your x. And then obviously you're going to have x squared plus 1 to the power minus a half. Remember, no negative. So this gives you further here x over x squared plus 1 to the power a half. No fractional powers, x over the square root of. Please, people, remember these no's. No negative, no fractional powers. Now I've solved du dx and I've solved dv dx. I go now to my formula sheet. Formula number dy dx. Formula number 8. That is u times dv dx plus v times du dx. People, in short, it is the first times the derivative of the second plus the second times the derivative of the first. This is what this means. In other words, what is u? U is 2x. I always put that in a round bracket and my derivatives in a square bracket. dv dx, can you see u, dv, v, du? Nice, ne? So u, 2x, dv dx, it's x over the root sign of x squared plus 1 plus v. Obviously, v was given as the square root. You give it the way it was given. You only need it in standard form for the derivative. And then 2. And we can just write it in a nicer form. This is 2x squared, because it's 2x squared, over the square root of x squared plus 1 plus obviously 2 times the square root of x squared plus 1. That's the final answer.
The quotient rule can be described as the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function, all over the bottom function squared. Work through the following examples on your own or in pairs. Differentiate the following with respect to x using the quotient rule. Number 1, y equals x to the 5 over x squared. Number 2, y equals sine x over cos x. Let's watch the solutions.
Differentiate with respect to x. Y is equal to x5 over x2. Hey, people. When you look at this question without reading the question, You might apply the exponent rule, which means you're completely off track. Please, it's very important that you read the question. We need to differentiate. What do we have here? We have the quotient of two algebraic expressions. My numerator is x to the power 5 and my denominator is x to the power 2. And for the quotient rule, we normally start off by saying, let u be equal to my numerator, which is x5, and v be equal to my denominator, which is x2. And then people, exactly the same procedure as it was the case with your product rule. Du dx is equal to 5x to the power 4 and dv dx is equal to 2x, obviously to the power 1. Now comes the difference. You go to your formula sheet, dy dx. It's always advisable to write down the formula and then apply it. You're going to have a line there. I normally said bottom squared, bottom, times derivative top, minus top, that's u, times derivative bottom. Please, people, this formula is on your formula sheet, formula number 9. And now you substitute. You draw your line and you start from the bottom. V squared, take note, V is x squared, but it must be squared. And then immediately V times derivative top, that's most now du dx, which is 5x4, minus top, which is x to the power 5, and then derivative bottom, which is 2x. And then you can just simplify it. This gives me 5x. 4 plus 2 is 6. Please, not 4 times 2. Bases are the same. You keep the base and you add. Minus 2x. Take note, 5 plus 1 is 6. Over, you can keep that like that, or you can say x. Yeah, because it's a bracket, x to the power 4. Let's continue on the other side, people. dy dx. Please, it's always important to note. 5x to the power 6 minus 2x to the power 6. Can you see those are the difference of two like terms? You will get 3x to the power 6 over x to the power 4. And now, people, you can now, remember, you can now apply your exponent laws, which will be 3x. Same basis, 6 minus 4. And your final answer here is 3x to the power 2. I have on purpose, you can see there it's not stated. They just said find the derivative, differentiate. I have on purpose applied the quotient rule to solve this problem. But if you use the exponent law there, by simplifying the y equals to x5 over x2, which will be x3, and then you find the derivative with regards to x3, you will get exactly 3x squared, which is a very interesting thing. Differentiate with respect to x. Here they give us direction, apply the quotient rule. In other words, y is equal to sine over x, meaning y is equal to u over v. So we start off by our statements. Let u be equal to my numerator, which is sine x, and v be equal to my denominator, which is cos x. Based on my formula sheet, du dx is equal to cos x. Also, formula sheet, dv dx, please people don't become gerook here, is equal to minus sine of x. And you can clearly see that on your formula sheet, formula number 15. Now you go to your formula sheet again, dy dx, formula number 9, v squared v du dx minus u dv dx. And then you just substitute. V squared, that is cos squared x, cos x. Du dx is equal to another cos x. Minus, just make this line longer, sin x, and then minus sin x, if you substitute directly. Then this gives me cos squared x. Very important, a minus times a minus gives you a plus sine squared x over cos squared x. According to my formula sheet, sine squared plus cos squared is equal to 1 over cos squared x. And this is equal to the reciprocal of sec squared x. And now people, sin x over cos x is equal to tan x. And based on my formula sheet, the derivative of tan x is equal to sec squared x. So what did we do here? We have proved that the derivative of tan x is equal to sec squared x by means of sin x and cos x.
Teaching tip. Students struggle to identify which rule to apply when. In the last few years, the examination papers have not expected students to decide which rule to apply. It has been given to them. However, students will have a better understanding of what they are doing if they do understand which rule should be applied. In particular, they need to distinguish between a composite function and the product or quotient of two functions, so that they know whether to apply the chain rule or when to apply the product or quotient rules.